Okay, so good evening, everyone. Today we'll be uh, talking about Module 3 topics, and the it won't be a very long session. Mostly we'll talk about the conceptual parts of it, because if you have done week 1 and 2, you'll be very good with APIs. And week 3 is basically interacting with a specialized API, right? I mean, that's effectively what it is. In this case, the API is able to generate some text or do some processing on some data that you send it. So that's basically what week 3 is, a specialized API. So, but there are some little more things to understand about it. So I'll talk about those things, the concepts behind it. And then once that's done, then I'll take any doubts. There'll be very less coding today because there's not much by way of demonstration that is needed to do for these things. Wherever it's required, I'll probably show some things. Okay. So first thing, if you've not so far managed to do it, but I hope all of you have by now, is to make sure you get your API key from this aipipe.org. When you go to week 3, the main page, it's the very first page that shows up. And you go to aipipe.org and you get your API key, you log in and you can get that. The big mistake most people do when they're running uh, any of the instructions given, they forget to give the right URL. It's most examples tend to have OpenAI's URL, whereas as I've explained in I think week 1, uh, we use a proxy which acts as an intermediary between you and the service provider. So the service provider could be OpenAI, or it could be Gemini, or it could be any one of those models out there. But you need to use the right URLs for it. It's all documented in here. So if you go to this documentation, you can see that there is a clear documentation on how to use this API. Okay. So that's something to keep in mind. There are a lot of discourse posts I've seen, and it's the same kind of issue over and over again, which is they say, I've run out of credits, but I haven't used any credits. That's why. Okay. Or I'll say you got the wrong key. So the key that AI pipe provides, which is the proxy key, is our key, right? It is not OpenAI's key. So you can't use our key in OpenAI's model directly, but you will be able to access OpenAI models through our proxy. I hope you guys understand what I'm saying when I mean by proxy, right? I know some of you are not from coding backgrounds. So if you didn't understand what I just said, can you either raise your hand or open your mic and say you did not understand? Or if it's clear, then I'll just move forward. Okay, that's good. Right. So then the next thing I'm going to talk about is how do LLMs actually work, and why that's of concern to us. So there are probably a lot of good videos on it, but I'll just give you a sort of brief overview of what they are, and so that'll probably help you when it comes to making some uh, or understanding what the issues you're facing are. Okay. So first of all, LLMs are not sentient. Okay, they are not some magical beings that designed in your machine or on any machine for that matter. At its very basic level, LLMs are effectively leverage a mathematical concept called transformers. And in effect, if you think about any sentence that you write, okay, to an LLM, these are made up of, these are broken down into some tokens. And each token may not necessarily be a word. Okay. So a word like token could possibly be two tokens. So what do I mean by tokens? When you enter a prompt, right? So for example, here for example, when you say to an LLM, what is 2 plus 2, right? That's a prompt that you give it. When you put in that input prompt, it is worth so many tokens, right? And that's how they charge you for the usage. Sorry, just give me a second here. Let me. Okay, so the tokens are effectively, you can think of them as parts of words, okay, or pieces of information that the LLM uses in order to respond to the things that you've given it. Now, internally, how it's represented by some huge multi-dimensional vector, probably in the order of, so about maybe 1,600 uh, feature vector. Okay, each token, each token is represented by 1,600 feature vector. So then next what happens is these vectors are all stored in a matrix of some sort. Okay, so now you got this massive matrix, and each of those tokens are represented by these vectors. And typically what happens is the vectors, the way the system or the way LLMs are designed, they look at the distances between these vectors, okay? And they make comparisons of these distances. So that's how they know if a word in a given context is related to one another or not. So in effect, LLMs are just large matrix operations, huge transformations that are occurring. And that's all that's happening under the hood. So that in effect is what gives us this output, right? So for a given input, if you think about functions, right? For a given input, there is a black box called LLM. It does some matrix transformations, okay? And then the output of that is some uh, uh, um, sentences that have gone through these transformations. So that is effectively what is happening as far as LLMs are concerned. Okay. The next thing to understand is there is something. So when you write a sentence, right? So if I say this animal was too tired to cross the road because it was tired.
Sir,
Okay.
where are you writing? It's showing nothing.
Sorry.
Oh, are you
Is
writing
it?
something?
Yeah, yeah. Is it not showing?
No, not visible, sir.
Sir, it's
Oh,
visible.
it's visible.
It's visible.
Is it for everyone? It's working. I mean, can you see? I wrote this sentence.
Yes,
This animal.
visible, sir. Sir, it's visible.
Okay, okay. It might be your connection. Okay, just check and see what the issue is. Right. So this animal was too tired to cross the road because it was tired. So there is something called attention. Okay. And what happens is when the LLM is breaking these all into tokens, okay, so many tokens, these tokens do something what is called, it references it does what's called self-attention. So it will look at this word it, for example. Okay. Now, it, the meaning of it can change depending on its context, right? So it's not just sufficient to know the distance of something from something else, right? It's got to be within the context. So here, a good question is, does it refer to the animal or does it refer to the road? Uh, these are an interesting question to ponder, right? So that's what self-attention is. So if you hear about self-attention in these transformer models, that's what self-attention is. It is trying to figure out what this is related to, right? And it does that for each and every token in here. And then that's how it it creates some set of probabilities. And then once it makes some probabilities about, so they say, for example, the road, it will give it a probability of 25%, and animal, it will give 65%, something like that, right? And then some other probabilities might be there. So then it will pick the most likely probability of what it will. So in other words, it makes some very educated guesses based on an underlying mathematical model. So this is how LLMs work. So the question is, okay, then how does it learn these things? So that's what, when you see in the news, they're building a big data center to train models. That's what they're doing. They're feeding these giant data centers, and it takes months and months and months and months for them to crunch through a whole bunch of training data that they give it. And then in the end, it produces a huge database of embeddings, okay, or vectors. And then those are what ultimately get used in the LLMs. Okay, so that's just a brief overview of conceptually what they are. Now, how does that help us? So how many of you know this disease called aphasia? Have you heard of this? Okay, so aphasia is a disease where a person who may be speaking something, right? But the words coming out of their mouth sometimes does not make sense. Okay, they're speaking words, but it does not make sense. And interestingly, a recent research paper, someone was considering this problem of LLMs hallucinating, right? Why do LLMs hallucinate? Or why sometimes it says things that sound sensible but are actually nonsense, right? You've all come across this, right? So it comes back to a problem which has got to do with context. When you, the biggest limitations for LLMs is it lacks a sense of context. So context is, now if you think about how old you are, right? You've been training your brain for 20, 30 years or whatever. And, but when someone asks you a question, you are still able to remember context from 20, 30 years ago, right? Likewise, when you're having a conversation with someone, you may speak to them for 2, 3 hours, right? And suddenly when they refer to something 3 hours ago, you're still able to carry on a meaningful conversation, right? Or if you're in an organization working on a project that you've been working for a year, you still have all the context in your mind. LLMs don't have that. Okay, they have a very limited context. And to give you a perspective, right, how limited they are. So the best models at the moment, until about a couple of months ago, it was roughly around 128,000 tokens. So not even a whole code base of any language could also fit in there. Okay, so that's how small the context window was. So that's why LLMs, sometimes what happens is when you're interacting with them, after some time, they will start giving you some nonsense suggestions, right? Because it has lost the context window. Somewhere down the line, it has forgotten what the conversation even was about. So that's the problem with context. Now, the latest models that come out recently, they've increased the context window to 1 million tokens. That's roughly the whole React code base context. So the whole of React code base can fit in that context. But when you think about it, right, that's still very small context. So that's why you have this issue with LLMs where they don't have sufficient context. So now that you understand it needs context to answer questions, you understand it has embeddings. Now we will talk about how we overcome some of these limitations so that we can make them reliable and useful tools.
Artem, just a question on the terms which you used.
Yeah.
So you said that it referring or finding context to whether it's related to road or animal, right?
Yeah.
It is known as self-reference and self-attention.
Yeah.
Is that
Self-attention. Yeah.
okay? Self-ref.
Self-attention. Yeah.
So
Self-attention is where
mm,
it's looking at what a given token in the context of where it's sitting refers to. So it creates some
okay.
probabilities to match it up with it.
Mm,
So,
mm,
like for example, in this sentence, right, it says
mm,
they rewrite your prompt and improve it. So, what does they refer to?
mm,
What does it refer to?
mm,
Depending on where it's sitting in the body of text, it can mean many different things, right? And there are
mm,
some probabilities associated with that. So, self attention is them looking to identify the best candidate for those words, which will then help it to create a response that is also meaningful. Okay, right. So I'll skip past this first part, and what I'll go next to is go to embeddings. Okay. So, so this is what are called embedding models, right? Embedding models convert text to numbers, and not just text. It can convert. You can have something called multimodal embeddings, where even images or audio can be converted into some set of vectors. What is the advantage of using embeddings is that rather than using tokenization directly, if you are able to uh, create embeddings for uh, data that you have, right? So if you look at a GPT, it has not been trained on everything. Okay, it doesn't have all the knowledge in the world. It's been trained on some specific data. What the data is, you don't know. Some companies don't share that information with you because that's part of what makes their models better or worse or whatever. But let's say, for example, you have your company has some data that is very specific to your domain, right? So then the question becomes, I want to use this data that I have, and I want to use a general purpose LLM to be trained on my set of data, right? So that's where this concept of embeddings, which I talked about earlier, becomes useful because you can do that um, in the same way locally on your system. So there is some code here, of course, that I'll let you explore on your own. Today, I want to just cover the concepts. And this is exactly what it is, right? So we create an embedding. So here, for example, we have this in this particular example, they have given apple and orange and apple and lightning, and it finds the similarities between those two. So this code basically encodes the embedding, and you can use different models to embed. Okay, so that's what this sentence transformer is using, this particular model. So where can you find good models? So if you go to Hugging Face, that's the one place where you can get a lot of freely available models to try. Okay, and you can see there is a leaderboard in Hugging Face, which tells you which models perform, how do they perform, what are the resources they consume. So you can use one that fits your use case. If you don't want something that's overly powerful and it's sufficient for your use case, then you can make that selection based on various criteria. OpenAI also has embeddings, but here what happens is you're using you will have to make a call to their server to do that. Okay, so that's one difference between locally embedding something versus making a call to them. So you can use their embeddings so that it fits within their model. So both ways are possible. Okay. Next, multimodal embeddings. So multimodal just means different types of embeddings. Okay, so usually embeddings refer to text, but in multimodal means you can do images and other things mapped to the same vector space. So why is that important? So if you remember in mathematics, right, in linear algebra, if something is in the same vector space, then you are able to do some direct operations that are meaningful, right? If they are not even in the same vector space, then the operations you do on them are not terribly meaningful. So the idea that you can map images, text, audio, all to the same vector space gives you something very powerful, which is some of you might have seen on your phones these days that you can ask on there, show me all pictures of, I don't know, cats or something like that, right? And it's amazingly able to organize all your pictures based on whether there's a cat or not. The reason it's able to do that is partly it uses ML, but the other aspect of it is it's a kind of multimodal embedding, right? Where the image and the text are mapped in the same space. So that's why they are able to figure out similarities between what you have written versus what's in an image. And so that's kind of the idea behind multimodal embeddings. Again, these are different models that are available. You are able to get some keys free for them and give them a try. And you just send them curl requests via the API to use them. And so you'll get a sense of how they work. Next, I'll talk about, so topic modeling is effectively what I was talking about earlier, right? Which is using embeddings to find similarities of things. This takes it a step further, okay? Which is, now let's say you've encoded all your data in your system, and you now want to give it a task or something to search that information with. And now normally searchers deal with keywords, right? If they match a keyword, then it shows up. But the problem with the keyword searching is it's severely limited because it doesn't get context, right? Keyword searching, that's been the big failure of keyword searching. That's why when you search on Google before, you would type some words and it will show you things that are not at all related, right, to what you are searching. That's because it doesn't understand the context of what you're searching for. Whereas with embeddings, you have a special superpower now, which is it's able to find the similarity between two vectors of what is stored in the database versus what you have written. So now the words don't have to match, but as long as the meaning matches, you're able to get a match. And so you're able to get more contextually relevant information. So that is what topic modeling is about, okay? And if you go here, right, so I hope all of you have gone through or take the effort to go through these things, right? There are a lot of resources we give here. So all I've done is open this Jupyter notebook here. And you can see, right, there's an already pre-made example here. So you can see how the API call is constructed. There are the three parts to it, the URL, the headers, and the JSON dump. And it's embedding, doing some embeddings here, finding similarities here, and clustering them into topics. And you can see over here, right, what embeddings are able to do. Yeah.
Can you please increase the font size?
Increase the font size, yeah, sorry. Okay, so this resource is available to you, but only if you took the effort to, go through this and actually explore all these links we give you. Okay, here's an embeddings guide, right? And it talks about what embeddings are in a bit more detail and what you can use them for. You can use them for anomaly detection. So for example, if you're looking at spam or something, right? You can use embeddings as a powerful way of deciding if something is spam or not, right? And all sorts of other types of capabilities are possible with embeddings. Then let me see if it is here. Okay, so there was a site, it will be in one of the references anyway, where you can type in a prompt and it will tell you what those tokens are, okay? and it will show you how it has tokenized them and broken them down. So I don't have it. I'm not sure which one it was, but it will be in one of these anyway. So that's about topic modeling. Okay, now the next problem is, once you created embeddings or created vectors, you might have a large body of them, right? For small tasks, it works in memory. That's great. But once it grows beyond a certain size, you can't keep it all in memory. So now you have to store it on disk, as it were. So this is where vector databases become very useful. The vectors that you created from the embeddings, you need to store them. And most of the popular databases now support vector searching. So DuckDB, SQLite, and Postgres, all of them support it. And it's very useful to be able to know how to store your embeddings on those DBs. Okay. And again, there is code here already available that uses the Chroma DB library or uses the Lance DB library and DuckDB library. So all these code examples are already there, created for you. Explore them, run them, tinker with them, see how it works, so that you're familiar with how these things work. Okay. Basically, you give it some document that you want to create vectors for, and then you store the embeddings into your database. Okay, so once you store these vectors into a database, the next question is, how do you get them, how do you use them for doing useful work, right? This is where this idea of RAG comes in. So RAG means retrieval augmented generation. Now remember, earlier I talked to you about context, right? A LLM has very limited context. So one of the ways to get out of that problem of context, which is it doesn't remember everything that you're talking about, is to use what's called retrieval augmented generation. So here what happens is you store all those things that you want documented. And when you ask an LLM a question, you force it to give a reference. Okay. So then what happens is it looks through the database and finds information, right, that is related directly to the context of what you are talking about. And that's what RAG is about. So the example we have given here is, we have taken some document, it's broken down into some chunks, okay, small pieces of information, and then embeddings are created, and then the similarity is found between the prompt input and what has been stored already. So it gets what is called the retrieved context, okay, which is where that RAG comes from. Because it can't remember everything. Even your GPT that is on your computer, you know, the one where you interact with OpenAI, they also do something similar, right? They can't store everything in memory. So they have to retrieve context. So this is how they get over that problem of hallucination, which is it has to refer to something that is stored and give reference to it, right? That's how you are able to retrieve the context, and it's able to reduce the amount of hallucination. It doesn't eliminate it, but it dramatically improves the accuracy of what it is saying. Okay. And of course, you have to give specific prompts that enables it to craft the answers correctly, right? So when you say things like answer only from these notes, right? Cite verbatim from notes. So then that ensures that any response it gives you comes directly from what is stored in your database. So that's what so this is when they say RAG, right? This is what they mean by that. Okay. Very important concept. This is a very important concept. When you go work in a professional setting, you're almost certainly going to come across this. Here at on campus, many of the departments now are already involved in converting their existing knowledge into a format that enables this RAG system. Okay, so whatever company is out there, medium to large, and eventually maybe even small companies, this will become very important going forward. Okay, And again, it's a way to get around the limitation of LLM hallucinations, which result from it having small context. So that's what RAGs are. Okay. Now the next problem you will face is, remember I told you with embeddings, when you do a keyword search, you have this issue where it's able to get you articles that are related, but they may not necessarily match the keywords that you have, right? And the context that it gets is a probability. It's most likely going to be these articles, but it may or may not be them also, right? So how do you get the best of both worlds? Because sometimes you really do want those keywords in your whatever search you're doing, right? So you want context, but you also want those keywords to be present. So the way to handle that is something called a hybrid RAG. Okay, and there is a special tool that's available that makes this possible, which combines the best of both worlds. It combines the keyword matching, so you get the precision of keyword matching, but it also uses the RAG model to retrieve relevant things. So TypeSense is one of those libraries that enable you to do it. Here we are running TypeSense within a Docker container. So you should be able to understand what this does. It's running it on internally on the port 8108, which is what TypeSense internally runs on the Docker container, and it makes it available to you on your 8108 port on your computer. Anyone knows what this line does? It's not related to LLMs, but I'm just curious because you've just finished week 2, right?
It's actually explained in front of us only. So
Sorry?
it's written, right? That it.
Right. Yeah. Oh, here. Yes. Yeah. So one of the issues with containers is they're ephemeral, right? So in other words, they don't persist, and any data that is created in them gets destroyed when the container disappears. But if you want the data to persist, then you have to give it this option where it mounts the information in a place where it's even after the container disappears, the data still remains. Okay, so that's what that is. Okay, so right. So again, this is about there are good code examples here. I would advise you to try them out and see how that works. Okay, any questions so far?
Yeah, the hybrid RAG thing. Can you explain again in terms of the example which you were talking about?
Yeah, so
we are getting context from the document, but then we need something more. Like in what sense?
Yeah, so sometimes you want keywords to match. Okay, you just don't want only context. Okay, because context is like a probability, right? This article may mostly be related. Then the next one it shows you might be a little bit less related and things of that sort. But sometimes you want direct keyword matching to exist even in the contextualized document. So that's when you use something like typesense, okay, where what keywords you're typing. So if I mean, a simple example is to just show you on Google, right? So when you type something here, right, what are felines? Okay, it didn't show up on here, but sometimes you'll get this Gemini producing some answer, right? Like some AI generated answer will sometimes appear on here. So when that answer appears on there, it'll show you it'll still have the keywords that you typed in there, but it will also give you some links to documents that you might find useful. And that usually shows up at the top over here, right? So in one sense, that's like a hybrid RAG where the keyword still matters, but you also want contextual documents that may or may not be directly related with the topic you're considering. So a good example of that is, imagine you're looking for something related with coding, okay, where you're looking for a very specific library about something. So you don't always necessarily if you just type the keyword and only do keyword searching, you might get a lot of rubbish results, okay? Because it's a library that might have been used in a completely different context that's not relevant to you. So keyword matching there was good, but it gave you lots of nonsense results. Whereas if you used type sense, right, not only will it give you contextual information, but it will make sure that that keyword exists in the context that it was discussing. So let's pretend, for example, you wanted to know about Podman, okay? Now, an embeddings database, for argument's sake, will say when you did a just a normal RAG, it gave you, instead of Podman, it gave you all Docker related things, okay? Which is great. It's contextually correct, but you still want specifically Podman related commands itself, right? So then what you do is you get the best of both worlds, which is you get the contextual information about Dockerization, but you get them with the keyword Podman in them. So that's what TypeSense does. Is that clear? Hello.
So it's like the response we are getting is the basically the context matching thing, but the links we are getting are the the rack part is the response, but the links are the contextual matching.
Yeah, you will get both. It will look at both the keywords as well as the context matching using RAG. So it combines both. So that's what it does and gives you responses based on that. Okay. Now the next topic I want to talk to you about. Okay, let's do one more thing. We'll go to this Base64 encoding. Okay. Now, one common problem in using generative AI is it's all text-based, right? So, but that does not mean you cannot use the transformer model for other things, right? Anything that can be represented by a vector effectively can work in a transformer model, right? We get rich context from images, audio, and it matches with natural language in many ways, right? So the question then is, how do we send that kind of information to a GPT of any sort, right? And this is where something called Base64 encoding comes in. What it does is it converts any binary data. So what is meant by binary data? So anything you see, right, in a computer, whether it's an image or any sort of file, all of them in the end are stored in what's called binary data, ones and zeros, right? And that's not particularly useful when it comes to LLMs, because LLMs still need text, because they're going to convert that text into tokens. The tokens then get converted into embeddings, etc. So in order to send the data to them, we have to convert it to some sort of text. And this is where Base64 comes in, right? It takes any 24 bits of, if you haven't seen this video, I highly recommend watching this video, okay? But what it does is it takes, here it says, yeah. So it takes any 24 bits of data, okay? So data, if you can think of it, there are so many kilobytes of information in an image, right? So it breaks them down into each of them into 24 bits of data, and then converts them into 4 bytes of data, okay? 3 bytes it takes, converts them into 4 bytes. Why is it 4 bytes? Because it can be represented as text characters. So that's why it converts them into 4 text characters. So then you are able to send even things like images, audio, etc. as text characters. It will be meaningless text because it's encoding, right? So it will look something like some gobbledygook like this. But it can be decoded back into the original image without loss of information. So there is no loss of information when this encoding and decoding happens. You encode it on here, send it to the GPT. GPT then decodes it back and reconstructs what is required, right? So this idea of Base64 encoding will be very useful for any of your applications that deal with images or audio.
It's mostly about sending data across the web, right? Because
Yes.
let's say, like we are saying, base64.url safety
Yeah.
base64 encode.
Yes.
So,
Yeah.
so that is why we are doing it, to actually just crunch the data in a format.
Yes. Correct. So one example of that is if you go to this vision models, right? How do you send, for example, an image, right? So here is an example, right? So they send it to the GPT, and you can see here it's sent in base64, right? So that's how the image has been sent to the GPT, and then you can do some useful things once you encode data and send it across. Right? Interestingly enough, that's how even videos work. Okay, so videos are nothing but uh, still images that are shown to you one after another. So typically, when you hear this FPS, right, frames per second, a video is typically something like, as long as it reaches at least 24 frames per second, to your eyes, they look like a moving image. Okay, so that's how movies are made or videos are made. And you can leverage this power, okay, of knowing that fact that actually videos are just still images, lots of them, to do useful computations on them. What do I mean by useful computations? So let's say, for example, you have security cam footage, right? And you decide, okay, I want to create an app now that is intelligent, that tells me when my cat is leaving the house and when it's coming inside, right? So instead of sending a continuous stream of data, right, to which is very intensive to your model that is working, you can send it just frame, one frame here, next frame after 10 seconds, next frame after 20 seconds. And then that way, you're able to still get the sense of what's happening, but you're able to do some useful computation from that, right? So how would you send a video? Basically, you would make calls that send effectively what are frames to the GPT model. Where has it been used? So I remember something that we are trialing. So in your what's it called? The exams that you do on in your home. I forget what they're called. OPPs, right? So there, something we are trialing is, and Anand is involved in this as well, which is the screen recording that's happened, right? Question is, how do you catch people that are cheating, right? So people who cheat have a certain what do you call for it, telltale signs of interaction with the machine. What do I mean by that? So you can see my screen now, right? So let's say this is an OPP, right? And there's a question up here, and there is a box over here, and you're typing something in here, right? So when someone is cheating, they tend to stay still for long periods of time, and then suddenly lots of things happen, right? Now, a human being is not going to catch this because there are thousands of students out there, tens of thousands of students, and they will not be able to, even if a proctor is there, they will not be able to catch that. But an LLM is able to catch that. So why? Because a normal human being, what do? They look at the question, then they go type some code, make some mistakes. Look at the question, type some code here, make some mistakes. Look at the code. That continuously happens with someone who is not cheating, right? Because they're actually working on the problem, right? Whereas these tell signs, an LLM is able to capture very quickly and flag these recorded videos as there is a high probability of cheating in this particular case, right? So this is where you leverage AI to look at vision, right, which is effectively a video, but it's actually just frames being sent to them, and we are able to then use a GPT to actually solve this problem for us, right? Something that we could not do before.
This is actually scary but brilliant at the same time, and should be used in the marketing of the course overall. I think, yeah, once it is operational, because
Yeah, yeah,
the exam integrity part, which some people may have a doubt on, that
yeah,
will definitely get eliminated altogether.
yeah, yeah. And we are able to see once they flag up things like this, we are able to then do follow-ups, right? So this is some things we are working on, but this is a very good example, right? Why is this valuable to learn? Why should I care about sending an image to a GPT, right? This is a good use case of it. Another use case is Anand's company Graminer. They wanted to improve workplace safety, right? So unless some human being is constantly 24/7 looking at workplace safety in a factory, you can't identify where potential problems may emerge, right? So there was a little video, I don't have it here, but there was a video, if you can imagine, there was a video of the factory floor and people working using tools, all sorts of things on there. And then you using normal text, this is the best part about it, right? Once the LLM has the whole video with it, using normal text, you can just ask it a question. You can say, what tool was this person using? And guess what? It's able to identify. Or you can say, where are the potential problems or where were safety violations potentially occurring? Then it takes you exactly to the position where it thinks safety violations are occurring. That's just amazing that you can do that, right? And how you do that? Basically, by sending frames. And you send frames and ask it to use that context to figure out what's going on, right? So that's why I wanted to talk a little bit about Base64 encoding and vision models. The same thing for vision models is also possible for audio models as well. Yes, yeah.
Sir, the results would be differing. I'm like on the basis of the quality of the video that we are sending.
You'd be surprised. The GPT is way better than sometimes people at identifying what's going on because it's able to deal with low quality much better than people can. So you would be surprised, and they're only getting better and better, right?
Okay.
I think part of it is because you're able to use some ML models to do reconstruction, right? Where things can be enhanced or improved. There was a
Yes.
movie made back in '96, I think. It was called Enemy of the State. If you have not seen it, I recommend you watch it. It's a bit old now, but there you can see, a lot of these things that you're talking about, right? Where they reconstruct what potentially someone has in a bag because of the shape of the bag or whatever it was, right? So it's a pretty good movie, Enemy of the State. So Will Smith was in that movie. I highly recommend. But anyway, okay. So that was about vision models. Okay, now I'll go to the top. So I spoke about all these things. At the end of the day, a model or whatever you use, yeah, any GPT you use, is only going to be as good as the prompt that you give it. Okay, this is where
Just one request. That ensuring workplace safety in factories using LLMs and like vision models. If there is any more resource on it, because I may have to build something around it for the work I do.
I'll just get in touch with Anand and ask him about it because I remember him demonstrating it for us in one of our sessions that we were having with him.
I hope Grammarly is not too expensive. If so, I'll probably work with them directly. Thank you.
Yeah. I mean, you can build it yourself also, right? It's not something impossible to do. But I'm sure he will be happy to share how it is done, right? The process, the concept behind it, and things of that sort.
Thank you so much.
Yeah. Okay, so in fact, you can write directly to him. I'm sure he will be happy to. He's always happy to interact with students. So that's one thing nice about TDS professor. All right, so all these things that we spoke about so far are not going to be terribly useful unless we get this right. Okay, term after term, we've been doing this now for about 3 or 4 terms, right? One of the main places where most of the students struggle, particularly when it comes to projects, is they don't give good enough prompts, right? This concept of prompt engineering, I know it sounds very self-inflating in some ways, right? It's saying, what is prompt engineering? Why can this be such a big deal? Believe me, this is super important, right? If you don't get this right, most of your quote unquote intelligent programs will not be scalable. That's the first thing. They will not be consistent. That's the second thing. And if they're not scalable and they're not consistent, then they're almost useless, right? You're never going to get to the stage where you can actually use it in production. How do you ensure that you get consistent, good results? You really should understand the concept of prompt engineering very well. And many examples have been given. Almost all students skip this part, right? Which is unfortunate. But if you want to get ahead in this field, which is the future, and every company out there is heavily engaged in this, you want to be good at prompt engineering. So some tips and examples are given. Okay, I'm not going to go through them. You can read them at your
I think
leisure.
the biggest tip is to document the prompts which end up working.
Yes, not only that's one tip, but I will show you something else as well. So first thing is make sure your prompts are detailed, very good, and yes, document the prompts. Whenever we construct our projects, we document everything. Prompts that are not working, prompts that are working, what the results of those prompts are. We log everything, okay? Because we learn from that body of work what is good practice, and we also see LLMs. I don't want to say they have a character, but they have some nuance to them, some personality to them, right? And until you understand its quote unquote personality, right, what it responds well to, etc., then you will not be able to get the most out of it, right, or consistent results out of it. So make it a practice to store everything when you're dealing with any specific model. So say, for example, you're using 4.1 nano. Okay, store all the prompts of nano, what you're sending, store all the outputs. But then when you change to 4.0 mini, right, again, you have to do that same test, okay, because it is not going to work the same as 4.1 nano. So what prompt worked well in 4.1 nano may not work well in 4.0 mini, right? So if a model changes, right, you'll have to rerun your tests to make sure that you're still getting the expected output. Another useful tip, so apart from how to write your prompts, right, there are some important tips here, okay? Using XML to structure the prompt. In other words, this is an instruction, this is an example. How will the LLM know? Because you're given these tags. So it knows now you're talking about an instruction, this is an example. So it's not just text, right? Almost all of you probably do this only, right? Almost rarely will you use XML to structure your prompts, right? So try to start practicing using these kind of techniques. Then Markdown to format the output. Very useful. Then using JSON, right? This is when you're getting structured data out, which I'll talk about in just a minute. So all these sorts of things that are talked about here, I strongly encourage you to not only go through in detail this first page and take to heart all the lessons in it, watch this video as well. And it will really help you to be much better at using LLMs for your projects. So that is about prompt engineering. And then we have shown some real examples, right? So how we constructed the TDS TA And the course material, all the course material on here was reviewed by the LLM, right? And this is the instructions we gave. Look how detailed the instructions are, right? This is one prompt that we have given it. Extremely detailed prompt. So that why we can give you good quality content. So it's a very important topic. Okay, that's why we gave like 3 sections all devoted to that. Sentiment analysis. It's not a very significant topic, but it's mainly to do with the fact that you give it a sentence, get the sentiment of a line, what it, whether it's good, bad, or that sort of thing. Again, there are Jupyter notebooks here. You can use them to play around with. It's not that it's not an important topic. Usually you can use sentiment analysis for lots of things. It's used in the real world in lots of things. So imagine you're making so I'll give you a simple example. Imagine you're making a smart bot to do trades for you, right, in the share market. And as its inputs, you're giving it information about articles from the Financial Times, right? And you want it to give you a recommendation, this intelligent bot, whether it is worth buying this stock or share or not, or to hold it or to sell it, right? So that's where sentiment analysis might come in, right? Yes, you have mathematical metrics, right? Some objective information you can look at, but that's not sufficient, right? If only objective information could give us predictions on the market, then we would have everyone making money in the market, right? Because you could just use a mathematical model that solves it all. But human beings are not that way, right? There are people involved in making decisions at companies that don't have to do with just the mathematics of it, right? So these articles, right, or these shareholder meetings where things are being said, how do you digest that information and produce a sentiment, right? Whether it is worth investing in this company or not. So one way to do that was to actually attend those meetings, right? But most of us, let's be truthful, right? If you've got shares and a shareholder, we almost rarely ever go to those meetings, right? Or even watch those meetings. We just want to get on with our life and have someone else manage it for us. So the someone else tends to be some mutual fund manager or something, and half the time they do a pretty bad job. What if we make an intelligent bot, right, which can do the job much better than a person? So sentiment analysis, important topic. I recommend you look at the Jupyter notebook here. You can see it's able to get the sentiment of these sentences. If you're running an election campaign, you want to know how the campaign is going. You're doing some internal metrics. Sentiment analysis is important. What the public views your policies, how they're viewing your things. How is the buzz on TikTok? Is it positive, negative? If people were involved in that process, it would be very expensive. But you could make a bot that probably does it, and it would give you a very good result. So sentiment analysis is a pretty important topic. This is, I know I keep saying things are important, but week 3 is life-changing for a lot of people, okay, who really take it to heart. So week 3, so this is about text extraction. One crucial, okay, it's 7:05 now. What we'll do is we'll take just a 5-minute break before I go into this next set of sections that I wanted to talk about, okay? We'll be back about 7:10. Is that okay? Any questions, by the way, so far before we break up?
I've noticed that in search engine optimization, a lot of scam websites can optimize, right, to rank higher. And even I think in case of LLM optimization, a lot of scammy sites have started to come in as suggestions of the LLM agents. Is that something that can be a problem? Like we are saying that our bot can actually analyze these reports and news reports. So maybe news reports and all these articles can be made in a way by maybe parallel bots, which can kind of poison the results.
Yeah, I mean, in some sense, that is possible. You'll have to come, see, that's what, you'll have to come up with some sort of paradigm to deal with the issues you will face, right? So one is deciding between what's a good source and a bad source. Maybe you curate a set of sources that you feel are will give you good information, right? So anything that comes out of Berkshire Hathaway, if anyone says anything from there is worth listening to, right? So in that sense, you'll have to curate what are good sources of information and then use that to feed your analysis of what you're doing.
Okay, thank you.
Sir, right now I'm not having any question related to this, but still I'm having some problem related to GA2. Can we discuss it in the end of the session?
Yeah. What specifically is it about?
One is compressing. I was
Okay.
using the tools that was suggesting in the assignment, but still it came to 551 KB. It didn't came under 400. So how should I approach it? One question, and one no more I am having.
Yeah, it's a difficult question. That's what I can tell you, because every term we are also tested by Anand in a sense, and it took us some time to get a handle on it as well. But it is solvable, and I'll give you some hints, okay, of how to deal with it. One mistake that I personally made when I was initially solving it is, so we were talking about, you have you done any ML or any of these topics, machine learning foundation or machine learning?
Yes, sir. I have done machine learning foundation. Now I'm learning machine learning techniques.
Okay, great. Then this tip might work for you. Okay. Well, the one clue I will give you is sometimes when you're compressing something, right? So the whole idea is to not lose critical information when compressing something, correct? You're throwing away useless features, but keeping useful features, correct?
Yes, sir.
Okay. So now when you think about image compression, something similar is happening, okay? And one mistake I personally made, and I don't know if you're making that mistake or not, is I threw away a useful feature before I did the compression. Okay, I thought there was a particular feature of the PNG. All of you get PNGs, right? There was a particular feature of the PNG that I accidentally threw away before the compression algorithm could start. And because I threw away that feature, which was actually useful, it was unable to compress it within the given size. So the point is, keep all the features of the PNG and run the compression algorithm. That's a hint I can give you.
Okay, so we have to keep the data, but there were some tools like 1 second. I'll just check the tools and tell you. 1 second.
Yeah, like Python, there was a Python tool or something, right?
Yeah, it was Pillow, but I also tried with other tools to just go through and more reduce the size. I tried everything. Let me just go through 1 second. 1 second.
Can you send me your roll number in the chat?
Roll number, yes. My roll number.
Honest.
I have sent.
Okay. So yeah, I'll have a look at this, not at the moment, but later I'll have a look at it and see what the issue. But one thing for certain is they are all compressible. Initially, I had written, so I'll freely admit this. Okay, initially I had written to Anand saying the question is too tough for students, and I gave a suggestion. I did a pull request on his GitHub, making the question easier for students, but he refused to accept my pull request. So So then that was like a challenge, right? You should be able to do it. So then eventually I figured out what the issue was and managed to solve it. So he expects you guys to solve it. It's solvable. That's the key part. Okay, so don't give up hope. Most likely, did you use GPT to generate your compression algorithm?
Yeah, actually, yes.
Okay.
Not
Ah,
algorithm. I was
yeah.
using the tools ImagePick, PGN Quant, and two more to do this.
Yeah,
Actually,
yeah.
suggested.
So sometimes GPT gives you bad code. Okay, it seems like it will give you good code and it will get part of the solution right, but here you might have to use your mind a little bit. Okay, to solve this problem. Now, one thing I will say is some people use GPT and it worked, but I'll tell you why it worked for them. It worked for them because their image happened to be not these edge case scenarios where bad code will fail. Okay. So, in other words, there are students who got an image that can be compressed with bad code. Whereas if you got an image that cannot be compressed with bad code, then it will, you are in that edge case, and you will have to think it through what exactly each line of code is actually doing.
Okay,
Yeah.
got it.
Best clue is don't throw away features until the very end when you have to actually do the compression. So remember, WebP is an algorithm developed by Google to compress PNGs, right? So there are some pieces of code floating out there that does some transformations to the PNG before compression. Avoid all those.
Okay, got it. Yes. One more thing. If the question I would not be able to solve, can you solve it in another session when the GA2 deadline is over?
Yeah. After the deadline is over, we are able to solve your question for you if you ask the question. Yeah. Before we can't, but after we will. Yeah. We have solutions for all of these things.
Okay.
Okay. Right. So next, very important use of LLMs. Text extraction. To give you an idea of how valuable this is, right? When we were running a business, right? The bulk of our time went in dealing with paperwork, right? And compliance is very important. Maintaining records is very important. And auditing is very important. And it doesn't matter how profitable a company you have, if you don't manage your documentation well, right? That's the end of your business. So, in this idea of LLM text extraction, right, a time-consuming thing is dealing with invoices, right? If you've got hundreds and hundreds and thousands of invoices and delivery notes and all sorts of things, right? Putting that into an information capture system these systems exist, but they are error prone. They are very expensive in terms of manpower, and there are a lot of issues with that, right? And we have some OCR type technologies and things of that sort, but they're all still very poor in terms of taking data in a complex format and then labeling it correctly, right? So this is the date of the invoice, this is the contact number of the supplier, etc. Extracting all that information is a significant process. Why am I telling you this? So we had the co-founder of an AI company come just, I think 2 weeks ago. And the problem they're trying to solve is exactly this one, right? Which is text extraction. Why? Because they believe, right, that there is for them, they believe they have $100 million market opportunity if they can solve this, right?
Carlton, can we have the name of the AI startup?
Hyperbots. Okay.
How do you spell it?
Hyperbots. I'll give it to you at the end of the session. Okay. So, and they, by the way, they are recruiting for AI and ML engineers from here, right? So if any of you guys are interested to do internships with them, they're happy to take you on. But this is a problem they're trying to solve, right? And it is worth a lot. Okay, not only to them, but to businesses all over the world, including small businesses, right? This is worth a lot. This is where
that solution.
Yeah. So LLM text extraction. What's great about this is the idea is from unstructured data, right, or semi-structured data to extract structured information. This is a crucial, critical thing to be able to do. And I would, if I were you, I would take a significant amount of my time to learn this properly, this concept. Effectively, what you do is you give it the usual system and user prompts, right? But the key here, the most important thing here, actually, I'll just reduce the size just a little bit. Yeah, the key over here is that how the response comes back to you. That is extremely important. You want the information to come back to you not as a prompt, not as a paragraph of text, because that's worthless. You want it to come back to you in absolutely properly structured output.
Hello?
So, sorry? Did someone say something? Is it? Okay. I don't know who that is. Right. And what do I mean by that, right? So imagine on an invoice, right? You had all these key fields that are sitting all over the paper. Some of it is handwritten, some of it is typed, some of it has images, all these sorts of things. You want, I'm not receiving voice. Am I audible to everyone?
Yes, sir, you are audible.
Okay. Akbar, it might be a problem on it. Yeah. Okay. Yeah. So so the idea is you give it a JSON structure. Okay. You give it a precise structure that you want your response back in. And so in other words, when so if you give it an invoice, you define the fields for it. You say, okay, I want the date of this invoice, I want the supplier's name, I want this. So all those things you tell it exactly. So you will give it key fields, explain what those fields are, and it should extract that information. When it gives you that information back, it should give it to you in a JSON format. Now, once it gives you that structured information back, you are now able to use that in your system in a systematic way, and you're able to use them in your whatever information storage retrieval system that you have, right? So it's a pretty important concept, this whole text extraction part. So there's a Jupyter notebook here, right? Okay, and here they're trying to extract the address information from it, right? So it's just a whole line of text, which is just a simple example, right? And you can see, if you look at how this is constructed, it wants, so first, this is a bad way of doing it, right? Where you give it a prompt and you just kind of do this, right? And then later they show you how to use a schema to do the same thing. So this is the schema. This is how you want the LLM to respond to you back, right? You want when it responds to you, you don't want paragraphs. You want a state, and the state must have a name and a code. You want it to give it a country, and you want it to have zip code. It should only respond to you this way. So this is the schema that you use to enable the LLM to respond to you precisely that way. Now, looking at this, you might see this is quite scary looking. It's understandable, but one thing you can do in this particular situation is you can always use GPT to help you construct these schemas, okay? But sometimes you might find issues or errors with the schemas even GPT generates. For that reason, I recommend you at least try to understand how these schemas are constructed, okay? And if you look back at here.
Carlton, is the schema thing which you are learning, is it the same? It's very similar to model context protocol?
Similar idea, which is where you want to interact with in a very specific format, right? So it's kind of a similar concept. Just let me close this. Okay, so so if you look at this, right, you can see how it's been constructed, and this is a example of. So what they did is they broke down what's happening over here, right? And you can see that when a schema is constructed, right, this is where it actually starts, where this word schema is. So if you look on this over here, this is where the schema actually starts, right? And then you must have so you see where these exclamation marks are, right? These are specific requirements to using OpenAI. So each company, so if you're using Anthropic, they will have their own schema system. Gemini will have its own. So you'll have to look at the documentation to see how they expect schemas to be constructed. Okay, so that's something you have to keep in mind. So just go through this, and my suggestion is try with a simple example, right? Try extracting structured information from a simple example. Not this session, but in the next session, we will do some actual examples, okay? So that you get some practice in understanding the concept. But for now, I want you to at least do some homework, right? Play around with it and get a feel for it. An extremely important topic, extracting structured data from unstructured data. Another example I can give you, this is an example that happened to us internally in TDS. A few terms ago, we were having election data, okay, which were scanned PDFs of varying quality, varying, formats, etc. And we wanted to use it in a project that students were doing. And it took us something like 2 weeks, okay, to put it into some structured table, all this information that we had gathered about elections since 1950s in India. Then at that time, LLMs were fairly new. So I thought, hey, let's give it a whirl and see if it can extract structured data. We spent 2 weeks on this, right? Me and Amit, and it was very painful. Okay, the process. But I one day decided to try LLM to do it, and it was mind blowing. Okay, if we had to programmatically do all the things that we wanted to do, right, which is creating bounding boxes to extract information from particular locations on a PDF, etc., etc. If we did it the traditional programmatic way, right, it would have taken us forever. Whereas here I just fed the PDF to LLM, and within like 15 seconds, it was able to get all the contextual information I wanted from that document. Now, of course, at that time, we were not fully experienced with how to do it at scale, because we can't feed thousands and thousands of PDF to it over GPT. That would have been too costly, prohibitive for us. But the point still remains the same, right? It's a very valuable skill to learn. And there are, believe it or not, you can make an entire business just out of learning this itself. Okay. So very valuable. LLM text extraction. Next thing I want to go over.
Are you referring to house elections?
Yes, yeah, the state by state elections, yeah. Nowadays, the government of India election board has cleaned it all up. But back in those days, they were just scanned PDFs. Okay. Nowadays, they have generated PDFs, which are much cleaner and easier to deal with. But when we were dealing with it, we were looking at the actual document that was from the 1950s or 60s or whatever. So you can imagine they were scanned pages. Okay. Next thing I want to talk to you about. Okay. Now something similarly supremely important, and this is where you make your applications intelligent. Okay. So far we just talked about the capabilities of LLMs, but we have not really talked about how we can make intelligent applications, right? So this is another concept where, and you will use some of this most likely in some of the things that you're working on at some point or another. Watch this video. It's a very good video. And what, let me just give me 1 second here. Okay, so function calling. Okay, now you all are familiar with writing functions in Python, right? So you'll have a Python program, and there'll be some function 1, function 2, and function 3. Okay, and they'll do various tasks. Okay, and this is all well and good. So you will have an application. So imagine you have a travel agent, right? And function 1 will say, for example, look at all the flights that are available from certain destination to certain destination. So there will be some arguments that go into this function, right? So there'll be a origin and destination. So that's great. Then function 2 might be something that creates a booking for you or something, right? So that's great. And then function 3 might be, I don't know, give you a review for a place or something. Okay. So you can have all these various functions in your program, and this will be sitting on a system somewhere, and you'll have either an agent in an office, right? Or you will be having a website that does these things for you, and you interact with them, etc. Okay, so far so good. But now, imagine, okay, everybody is doing this, right? This is something common. Now you decide, okay, to do a startup, okay, a travel agent startup, and all your customer has to do, okay, is go on the phone, right? And on the phone, the customer can just directly speak on the phone and say, can you give me suggestions of places that have good nightlife? And I want you to find the first available flight next weekend and book a ticket for me. If they say that, right? How will you manage to do that in the traditional setup? You can't, right? It's a time-consuming process. And given the choice, if you could just quote unquote speak to a personal assistant, right? Like you have a PA. Imagine you having a PA or something, right? Where you tell your personal assistant and it just does it. Okay. And versus you having to go through this whole process. Which application you think will really make the money? It's going to be this one, right? This is going to be truly revolutionary, right? So how do we achieve that using what we have learned, right? So that's what function calling is about. Your LLM is going to take some prompt, okay? It will come in natural language. And you know what's the best part about this? It can be in any language. It can be in Hindi, it can be in Malayalam, it can be Tamil, English, anything. And it will still be able to handle your query without any issues. So how do we achieve that using what's called function calling? So it's simple, okay? In function calling, we'll again create a schema. You remember I was telling you about schemas earlier? So in that schema, we will tell the LLM, okay, look, you're going to get a prompt, okay? Something is going to come in. And when you get that information, I have a system sitting here that has some predefined capabilities, okay? And when interacting with the customer or this prompt that comes in, I will tell you what to extract from this prompt, okay? I want you to extract any origin information, any destination information, any booking related information, so passenger name, etc., and other types of things, right? So we'll have some predefined, almost you can say as roots, okay? But they're actually functions, predefined functions that the LLM can call from there directly into your system, okay? And that is what LLM function calling is about. But the way we define these are what is the learning part of it, right? How it processes this information and the workflow that deals with this issue. So when we say about workflow, so imagine the passenger or whoever the customer gave incomplete information, right? They said these things, you're able to find the origin and destination, but you don't have enough information for the booking. So what you will have is you'll have a workflow, right? That says, okay, customer gave this information. These are the functions you call, but I'm missing these pieces of information. Get that from the customer back, right? And then once you get those back, it's able to feed that back into these functions over here. So that is essentially what function calling is. It is telling the LLM that there are some predefined capabilities in your backend system. And you tell the LLM what those backend functions do in natural language. And then it extracts the information from any interactions that it gets and runs only those functions and runs them precisely and gives an output back to the customer. That is in a nutshell what function calling is. A supremely useful, powerful capability of using natural language to make intelligent programs. Another use case is, imagine your company has a database, right? And now at the moment to interact with the database, you need to write SQL commands against it, or you will have your database developer have some predefined SQL commands that are on it. Or if you own the company and you have a developer create a front end for you, they can only do those predefined tasks, right? But businesses constantly ask new questions, right? Business owners ask questions that they have not asked before because they want some new intuition into their data that they have. So what do you have to end up doing? You contact the developer will take time, a whole month will pass by. In the meanwhile, you missed the crucial window to make some important decisions concerning your business. But using this concept, right, of using natural language, you can construct, right, a system where it will transform your natural query into an SQL command that it will run on your backend system, right, to get the information that you asked without having to go through this whole rigmarole of building a UI and building other components that are expensive, unnecessary, and maybe only one-time use, right? That's the keyword. I might ask a question, I might find the answer and decide, it's okay, I don't want to deal with that, right? Whereas if in the traditional system, what you would have had to do, you had to pay the developer, you had to pay the people who maintain your system, ask the stupid question, and it cost you a whole bunch of money and you didn't get anything for it, right? We can fix those issues with using function calling. So very important to know this concept. Let me.
Carlton, just
Yeah.
like in basically what we are saying is in the schema of the prompt or query which we are doing, the schema we are basically telling that some functions are existing in our backend system and they will have certain inputs and things, right?
Correct.
So okay, you're about to explain that one.
Yeah. So this is an example, right? So this is a function definition for scheduling a meeting. So when you look here, right, it tells you how to construct it. So there's a type, there's a function. The function is called schedule a meeting. It tells you what the parameters are, and it tells it should have a date. So if you see this required part, right, scheduling a meeting requires date, time, and meeting room. And it tells you. So these are objects. Date, it's a string and it'll be in this format. Time is a string and it'll be in this format. Meeting, it'll be in this format. And this is informing the LLM what to do with your prompts that are coming, right? So what I explained to you was a fairly big example, but imagine making apps that are intelligent this way, right? Where you can just speak to your phone and it does these things, right? You can construct these apps using the idea of function calling. And the next thing is, so that was for a single function. Here's an example for define multiple functions. So you create something, you can do something called tools, and you give it a set of functions, right? So this is one function, right? Get expense balance. This is another function, right? Calculate performance bonus. And again, you have defined the parameters to the LLM, okay, what you're expecting. And then when you feed it natural information, it calls the correct function in your actual application and is able to then deal with the whatever the outcome that you wanted. So very important topic, function calling. The final thing I want to talk to you today about is, this is just about agents. Again, the whole idea behind agents is in all these things that we talked about. So that doesn't mean not to go through all this. All of this is very valuable. Week 3 is valuable. Okay, so don't skip anything. But I've tried to take it in a logical manner because some of these things are interspersed a bit here and there. But hopefully I've made a cohesive argument for you of what to learn and why to learn it.
We are saying that tools are basically list of the schema, right?
Yes. So if I go back here, tools are the lists of schemas. So there will be, so you can see over here, it's a list. And these are the various functions that will be called within your application. So one example was last term, I think it was, or term before. We would tell the application, okay, we want you to give us a JSON response. JSON response must have these. So for example, in this case, if you see employee ID and current year, it will respond back to us with these details. Then our application takes those details and puts it into the function. But before, there was no way of extracting this from natural language, right? Hello?
Hello?
Yeah.
Can you repeat the last thing you asked?
Yeah, so before, right, there was no way of extracting this kind of information from natural language, correct?
It was not there.
Yeah. So that's what we are leveraging, the ability of LLMs to understand natural language to do structured tasks. So that's what function calling is. It's bridging that gap between our structured code bases and unstructured prompts or unstructured commands or natural.
Okay, I'm plugging in something. Sorry for that, but MCP, this model context protocol thing, is just basically if the service provider made those schemas for you, right?
Yes. So it's the same idea. You have an API They tell you, okay, to interact with the system, these are the things we require. And you then provide a model that gets the information that you require for that particular system, and then you send that information to the system. So
Okay, so just a wild idea. If because it is so similar and it is something which is being talked about a lot, why not incorporate it in the TDS syllabus? Because we are anyway learning about it.
yeah, I mean, of course, I mean, the thing is, there is a lot to cover, right? So until we get the basics done, it is hard to go on to
Yeah. Okay.
something more,
Yeah.
right? I mean, because MCP is covered in year 3 anyway. They have, I think one of the subjects, they cover these aspects of it. So that's why in TDS, we decided not to do it.
Okay,
Because,
thank you.
yeah,
Understood.
because they will go into more detail of those sorts of things in later courses in year 3. But at least we want to lay the foundation for you of, I mean, if you learn this much itself, you can do a lot, right? So, and then other things you can, of course, pick up along the way. Okay, one final thing. We've talked about all the capabilities and what the uses of LLMs are. And I talked about the very big importance of prompt engineering. Now, how do we test how well our systems are working? That is something very extremely important to be able to do. And this last section here, okay, LLM evals, I recommend you watch this video very carefully. Sorry, that one. Yeah, watch this video very carefully. Try out the examples he has given. He has a repository as well and things of that sort. Because what he uses, right, which is the ability to test LLMs with prompt foo, okay? And effectively what he does is, I wish I had an example here. Okay. Okay, anyway. So essentially creates a YAML file, okay? And in the YAML file, he gives a prompt, okay? And the prompt will have some, what you call variables, different kinds of things he wants to test. So these are the prompts he wants to test. He provides the models he wants to test. And then he creates the actual tests, okay? Which so if you know about testing in Python, you have assertions, right? So something similar to that. He'll create some assertions that enables him to score how well the prompting worked, okay? Whether it actually succeeded in doing what you expect it to do. So one thing is, so this assertion contains all means it should have these words, open source and LLM in its response, okay? So that's one kind of test he has done here, okay? I mean, this can be anything, okay? But this is just an example of a test. So that's what contains all means. Then LLM rubric, he's giving a rubric for to an agent to tell how it performed based on this rubric. So that's another way to do testing, okay? So why is this useful? If you watch the video, he's given a very fantastic example. And again, we will show some examples in the next session. He took the model 4.0 mini. He took the model 3.5, I think it was. He ran some prompts against them. And he tested it for how many tokens did it consume, how fast did it respond, and this what you call prompt foo will do that, okay? Or that all stuff it will do automatically. You just have to construct the YAML like this, the prompts, the providers that you want to test against, and the tests. And once he did that, he found for his particular use case that actually 3.5 did the test. Both of them succeeded in the test he gave. In all the tests he gave, there were 6 tests. Both of them 100% success was there. But 3.5 was able to give the answer in 1/10 the number of tokens and in quarter the time that it took 4.0 to do it. So from a business case perspective, right, that is huge. Because if you say, for example, are creating an application that is scaling and is getting thousands of requests, if something costs you 1/10 the money and performance-wise it does it in quarter of the time, it's huge, right? I mean, that is the difference between succeeding as an application or not. So the other thing it helps you, these tests, right, these evaluations, it helps you to make sure that 3 things. One is your prompts are giving you consistent results. Your prompts are cost effective, and your prompts are not regressing. Okay, what do I mean by regression? So models keep changing all the time, right? They keep updating. So as in his test case, he demonstrated that although the model went to 4.0 became available, 3.5 still performed good for his particular use case. So, but sometimes what happens is a model may change and your capability of an application might actually decrease because it's not responding to the prompt the way you expected it to. How do you test that? You use something like prompt 4. So this becomes very useful when you're designing commercial applications, right? For small projects, personal projects, all this is okay. But the minute you decide you want to do something commercially viable, right, then something like this becomes supremely important, where you want to make sure that your application has the performance that you're expecting, has the cost effectiveness that you're expecting, and that any changes is not causing it to lose capability. Because that's the issue with LLMs, right? They are not, they may not necessarily be 100% correct all the time, right? So the quality of your prompt will matter to improve its accuracy. So this is the reason why you should definitely learn prompt and how to use it for learning how to build commercial AI applications. Okay, so that covers week 3. I hope you've had a good overview of everything that week 3. I know there was not much code in it, but the reason is if I just start getting into the weeds straight away, then you will not get the value in understanding the concepts and why we use them.
Carlton, just one thing, like you said that this kind of testing is important for commercial projects and a model should be cost effective, have quality and not lose features. Now,
Yeah.
on the not lose features part, I've seen that some models are getting sunset. They're being shut down. They're being like newer models are better, so we are just closing out on the previous models.
Yeah.
Right. So in that case, folks who must have built applications using those APIs, right? So what happens to them? So maybe in terms of not losing features, that kind of parameter.
I mean, yeah. So that's a good question, right? One thing to realize is, for example, this works. Of course, it works with online models as well. But in the future, I expect it will work with also offline models as well. I haven't tried it out myself. But one way to avoid this problem of feature sunsetting is you have open source models that are maintained, right? And then you can, once you have them on your system, they just last forever, right? So in that sense, you can protect against that situation. With online models like OpenAI, of course, you can't do anything about it. But this is where, learning OLAMA and Hugging Face and how to locally have models installed and things of that sort will be of value. And you'll have to look through this. I haven't checked it myself. But Prompt4 might have the ability to interact with models locally as well. Okay. But it's something I haven't checked. I have to actually check if it can or not. But I suspect it can because it says it's got OLAMA on here. So I suspect it's able to deal with it. Okay. Are there any questions? I hope this session was useful to you guys, because in the past few sessions, people have said, right, you don't understand why you're learning what you're learning. So we decided to try and go over the concepts first, and then we will get into some coding in the later sessions. Okay.
To share some resources.
So this is full of resources, right? From top to bottom. This is the resource. I mean, every bit of it is valuable. So just go through them. And there are Jupyter notebooks, already pre-created code. I mean, if you look at this pricing, I think I saw the tokenizer here. And yeah, so if you look at here, right, these are the tokens. See, of course, this is for OpenAI, but notice this tokenizer is 2 tokens, and then you can see what it looks like in like previous models and things of that sort. And then, of course, once you know the number of tokens, you can know the cost. And for OpenAI, it's roughly 3/4 of a word usually. So 100 tokens is usually 75 words, things like that. Anyway. Yeah, so it's full of resources, very, very good resources. So my suggestion is go through this week 3, module 3. It's full of fantastic resources. Okay. And then next, tomorrow session, we'll do code examples. In particular, I would say we will do definitely function calling will be one of them. We will do some embeddings. We will deal with RAG, prompt foo we will show you. So some of these sorts of things we will show you how to do them. Okay. Okay. I'll bring this session to a close.
Thank you so much, sir.
Yeah. Thank you guys for attending. It would be very boring if no one attended.